describing matter. This is the second of 5 PowerPoint presentations given in Mr. Voigt's physical science class, all in the unit Introduction to Matter. So again, this PowerPoint is describing matter. The essential question is, what causes change? We're continuing to work on this question. What causes change? It's kind of a big question, but again, it's an important one because our opinions to this question may change over the course of the unit. The objective for today's lesson is to give examples of matter's different physical and chemical properties. At the end of this video, you should be able to list some different physical and chemical properties. Now, let's review what we already know. We already know that matter has both mass and volume. All matter has both mass and volume. Again, what is mass? And what is volume? Mass is the amount of stuff that something is made of. Volume is the amount of space that something occupies. Okay. All matter is different. They all share those two things in common. All matter has both mass and volume. But the things around us are different. Our desk is different than our pen and our pencil and the sink and the countertop and the computer. All that stuff is different and has different physical and chemical properties. Matter has physical and chemical properties that differentiate one type of matter from another. The properties make everything unique. Now, what's the difference between chemical and physical properties? Chemical properties describe a substance based on its ability to change into a new substance with new properties. And we're going to investigate chemical properties more in depth later on. But when a substance undergoes a chemical change, it becomes something entirely new. When wood burns, for example, it's no longer wood, it's something different. Symptoms of a chemical change include gas formation, unexpected color change, odor formation, or energy transfer. So when you feel something getting hot or you feel it getting cold, then it's undergoing a chemical change. A good example of that would be the ice packs that the nurse gives you. When you pop that seal on the inside and you shake it up, it starts to get cold. That's an energy transfer, and thereby indicating that a chemical change is occurring. Now, this change cannot be reversed by ordinary physical means. You cannot take that ice pack and put it back to the way that it was and reuse it. Physical properties can be observed and or measured without changing the identity of the substance. When a substance undergoes a physical change, it might look different, but it maintains its identity. This process can be reversed by physical means. The easiest example of that is water. So you take water out of the freezer and it's in the form of ice, solid water. You leave that ice on the counter for some period of time and it's going to turn into liquid water. And again, over time that water will eventually evaporate and turn into water vapor or a gas. And then of course, that gas could condense on a cold surface and turn into a liquid, and then if it gets cold enough it could freeze again. So we can go back and forth among the different phases of matter between a solid, liquid, and a gas, but the fact is it's still water the entire time. Now, there's many examples of physical properties. The first is thermal conductivity. That's the ability to transfer thermal energy from one area on the object to another. For example, your metal pots and pans have good thermal conductivity, which is why we use them to cook things. We want the heat to transfer from the bottom of the pan to the top of the pan. State is the physical form in which a substance exists, such as solid, liquid, or gas. Malleability is the ability to be pounded into thin sheets. Aluminum has good malleability, which is why we can take a chunk of aluminum and make, thousands of feet of aluminum foil. Solubility is the ability to dissolve in another substance, typically water, and we can check out how solubility occurs. Ductility is the ability to be drawn into wires. The melting point is the temperature at which the substance changes from a solid to a liquid. The boiling point is the temperature at which the substance changes from a liquid to a gas. Again, I would suggest that you become familiar with these different physical properties of matter. And I do suggest that you watch the video or check out the animation for solubility. Both can be found by accessing the website. Density is the last physical property, and that's the amount of the substance in a given space. Now, of those physical properties, only some of them are what we call characteristic properties. Characteristic properties of a substance are always the same whether the sample you're observing is big or small. So The density of water, for example, is always the same, no matter if you have one small cup of water or if you have a big full ocean of water. The density of water does not change. We can use characteristic properties to identify a substance, which is why they're called characteristic properties. For example, I've already mentioned density. We can also use melting point and boiling point, and some others to identify what substances are. For example, water is the only substance that has a density of 1 gram per milliliter, has a melting point of 0 degrees Celsius, and a boiling point of 100 degrees Celsius. So if I have an unknown liquid that's clear, colorless, looks like water, and has a density of the same as water, the melting point is the same as water, and the boiling point is the same as water, I can be certain that it's water. Let's take a deeper look at density. Density is a valuable physical property. It's also a characteristic property, which means that each substance has its own unique density. Density is a measure of how much stuff is in a certain area. The density of water, for example, is 1 gram per milliliter. That means that in every 1 milliliter of water, there is 1 gram of stuff, and that stuff, of course, is water molecules. Do the math break on page 13 of your textbook for more practice. Now, in class, we did a gold penny lab. Now, in this gold penny demonstration, we're going to change copper pennies into silver and then gold. Now, of course, we're not actually changing them into real silver and real gold, but we're going to change them into something that looks like silver and then something that looks like gold. The question I have then is this a physical or a chemical change? And to answer that question, you should ask yourself, can it be reversed? Now, what is the difference between a chemical change and a physical change? The difference is that we can reverse a physical change, but we cannot reverse a chemical change, at least not by ordinary chemical or physical means. So, if we take our penny and we change it into a silver penny, and that silver stuff just rubbed off, then that would be a physical change. We, of course, would learn that the silver does not rub off the penny, indicating that we, of course, completed a chemical change. And then, of course, when we heat the silver penny, the silver then and the copper underneath blend together and form a metal alloy, which is called brass. Now that is another chemical change.